Imagine you're relaxing on a tropical beach in Hawaii, watching gentle waves roll onto the shore. The sun is shining, the ocean looks perfectly calm, and everything feels peaceful. But at that exact moment, nearly 5,000 kilometers away, beneath the deep Pacific Ocean, the seafloor suddenly cracks. An enormous earthquake shakes the ocean floor for just a few minutes, releasing more energy than hundreds of nuclear bombs. Within seconds, a wave is born that will race across the ocean faster than a commercial jet. Yet, out in the open sea, almost no one would even notice it. How can one of nature's most destructive forces travel across an entire ocean almost invisible? And why does it seem to speed across deep water before transforming into a towering wall of destruction near the coast? Welcome to Science Meets Adventure, where we explore the incredible science behind our world's greatest adventures. To understand this mystery, we first need to forget almost everything we think we know about waves. The waves you see while surfing or relaxing on the beach are created mostly by wind. A tsunami is completely different. It's not just the water on the surface moving around. Instead, an underwater earthquake, volcanic eruption, or massive landslide suddenly lifts or drops an enormous section of the seafloor. Imagine lifting one end of a giant swimming pool. Every drop of water above it is pushed upward at once. That enormous movement creates a wave carrying energy through the entire depth of the ocean, from the surface all the way to the seabed. Here's the surprising part. Out in the deep ocean, a tsunami might be less than 1 meter tall. If you were standing on the deck of a large ship, you might not even realize you had just passed over one. Instead of looking like the giant curling waves seen in movies, a tsunami in deep water is more like a gentle rise and fall, stretching over hundreds of kilometers. Its power isn't in its height, it's hidden in its incredible length and the enormous amount of water moving beneath the surface. But then comes an even bigger mystery. Why does it travel so fast? Unlike ordinary wind waves, the speed of a tsunami depends almost entirely on the depth of the ocean. The deeper the water, the faster the wave moves. In the deepest parts of the Pacific Ocean, where the water is around 5,000 meters deep, a tsunami can reach speeds of more than 800 kilometers per hour, almost as fast as a passenger airplane. It's as if the ocean itself becomes a giant highway, allowing the wave to race from one continent to another in just a few hours. Imagine dropping a pebble into a shallow puddle. The ripples move slowly because they quickly interact with the bottom. Now, imagine an ocean thousands of meters deep. There's much more space for the energy to move freely, allowing the tsunami to travel with astonishing speed. Scientists even calculate its speed using a surprisingly simple equation based on gravity and water depth. In other words, the deeper the ocean, the faster the tsunami travels. This explains how the devastating 2004 Indian Ocean tsunami reached countries thousands of kilometers away from its source near Indonesia. Entire coastlines in Thailand, Sri Lanka, India, and even parts of East Africa were struck hours after the earthquake. Many people had no idea that a disaster that began far beyond the horizon was silently heading toward them. But if the tsunami moves so quickly across the open ocean, why does it suddenly become so destructive near land? The answer lies beneath the waves. As the tsunami approaches shallow coastal waters, the ocean floor begins to slow the bottom of the wave. The front loses speed, but the enormous amount of energy behind it keeps pushing forward. Since that energy has nowhere else to go, the water begins to pile upward. The wave slows down, but it grows dramatically taller, sometimes reaching heights of more than 30 meters. It's similar to cars on a busy highway suddenly approaching a traffic jam. The vehicles slow down and bunch together, creating a massive backup. A tsunami behaves in much the same way. The shape of the coastline can make things even worse. Narrow bays, river mouths, and funnel-shaped harbors squeeze the water into smaller spaces, forcing it to rise even higher. This is why neighboring beaches can experience completely different tsunami heights. Some islands even redirect or reflect the wave, concentrating its energy in unexpected places. Understanding local geography is one reason tsunami hazard maps are so important for coastal communities and travelers alike. The 2011 tsunami in Japan showed just how powerful this process can be. Triggered by one of the strongest earthquakes ever recorded, the tsunami crossed the Pacific Ocean, reached Hawaii, continued toward North America, and was detected along coastlines thousands of kilometers away. Although it lost energy during its journey, the wave demonstrated that no ocean is truly too large for a tsunami to cross. Nature also offers fascinating clues before a tsunami arrives. In some cases, people report seeing the ocean suddenly retreat hundreds of meters from the shoreline, exposing rocks, coral reefs, and fish normally hidden underwater. It may look like an incredible opportunity to explore the seabed, but it is actually one of the strongest warning signs imaginable. If you ever witness the sea rapidly pulling back after a strong or long earthquake, don't stop to take photos. Move immediately to higher ground. Every second matters. Scientists have built remarkable warning systems to help save lives. Networks of underwater pressure sensors, floating buoys, coastal tide gauges, GPS satellites, and seismic monitoring stations constantly watch the world's oceans. When a major underwater earthquake occurs, computers estimate whether a tsunami has formed and predict when it could reach different coastlines. These alerts give communities precious minutes or even hours to evacuate before the first waves arrive. There are also several surprising facts that many travelers never learn. A tsunami is rarely just one wave. It usually arrives as a series of waves that can continue for many hours. The first wave is not always the largest, which means returning to the beach too soon can be deadly. Even animals sometimes appear to sense danger before humans, with elephants, birds, and other wildlife moving inland before some historic tsunamis, although scientists are still studying exactly how they detect these changes. For anyone who loves traveling to beautiful coastal destinations, the best souvenir you can bring home is knowledge. Learn the local evacuation routes before visiting beaches in tsunami-prone regions. Pay attention to warning sirens and emergency alerts. If you feel a powerful earthquake that makes it difficult to stand, don't wait for an official warning. Head to higher ground immediately. The ocean is breathtaking, but it always deserves respect. The next time you stand beside the sea, remember that beneath its calm blue surface lies one of the most powerful transportation systems on Earth, capable of carrying enormous waves across entire oceans at incredible speeds. It's a reminder that our planet is alive, constantly moving beneath our feet in ways we rarely notice. Understanding these forces doesn't make the ocean less beautiful, it makes every coastline even more extraordinary. If you enjoyed exploring the science behind our amazing planet, don't forget to like this video, share it with fellow explorers, and subscribe to Science Meets Adventure for more incredible journeys into the science of our world. We'll see you in the next adventure.